Review problem number 7, and the game is assume that F is a bijection and show that F inverse is a bijection. Now, this is a pretty formal argument. I don't know if they gave you a specific domain and range, but this is true for any domain and any range in any kind of setting. So, to show that F inverse is a bijection, you have to show two things. That F inverse is onto, is that a term you use? And that F inverse is 1-to-1. Got to show those two things. So let's first show that F inverse is onto. F inverse is onto. Pick a. I think we're going to need to name the set. So this is going to be from a set X to a set Y. And I'll put a double-ended arrow there to indicate that it's onto. And I'll put a little feather on the front end of the arrow to indicate that it's 1-to-1. I don't know if you guys do that or not, but that says 1-to-1, that says onto, notationally speaking. So anyway, let Y, let's see, so F inverse, of course, goes from Y back to X. So let X be some element of X. And what we have to show is that there's a Y which F inverse maps to X. And so we can let Y be F of X. Then F inverse of Y is X, right? By definition of the inverse function. And so whatever that Y is, that F maps X to, F inverse maps back to X, and therefore X is in the range of F to the minus 1. So that shows that it's onto. Now let's show that F inverse is 1-to-1. So remember, 1-to-1 means that if you take two distinct elements in the domain, they map to distinct elements in the range. Now the domain for F inverse is Y. So let's let Y1 and Y2 be elements of Y that are not equal. Well, so Y1 is not equal to Y2. And define X1 to be F inverse of Y1, and define X2 to be F inverse of Y2. And what do we know about X1 and X2? We know that F maps X1 to Y1 by definition of F inverse, and F maps X2 to Y2. So if x1 were to be equal to x2, y1 is not equal to y2, this contradicts the definition of function. In other words, f is supposed to be a function. It can't map the same thing to two different things in its range. So if x1 equals x2, then certainly f of x1 would have to be equal to f of x2, but we've assumed that they're not equal, and therefore x1 must be different from x2. So we started off with two things in the domain of f inverse, assume that they're not equal, and conclude that their values are not equal, and that shows that f inverse is 1 to 1.